Good morning. This is Tim Stewart. I am president at Visual Decisions, and we're here today to talk about reducing the cash-to-cash conversion time with Industry 4.0 and operational excellence. At Visual Decisions, we've been in the business of utilizing information from the shop floor to improve operations since about 2002. We help our customers combine the smart factory with the lean factory to drive improvements to cost, throughput, and quality. So with that, let's go ahead and get started. All right, so if we look at the definition of the cash cycle or the cash conversion, this is kind of a simplified view. So looking at a single product with basically a single raw material, we can see when the order is placed for the raw material at the very beginning, when delivery happens and invoicing occurs, how long it takes for those raw materials before they're picked for production. Then those materials spend time in process, going through the manufacturing process. When production is complete, those finished goods inventory are placed into inventory. And then eventually they get sold and invoiced out to the customer. And when we receive payment from the customer for those items, then we kind of close that cycle. And so the amount of time that we have to spend between when we buy the raw materials and when we receive payment for the finished goods is our cash-to-cash conversion cycle. And so if we look at how we can start to improve how much cash we have tied up in this, first of all, we can certainly look at financial strategies. What are our terms out to our suppliers for when we have to pay them? Obviously, the longer that we can take before we pay our suppliers, the shorter our cash conversion cycle will be. And then, how quickly we can get paid by our customers is the other thing that will help, reduce this from a financial strategy point of view. So then we can also look at supply chain and production strategies, so that we reduce the amount of time that materials spend in inventory or in production. And that will also help us reduce our cash-to-cash cycle time. Now, I said that this is a simplified view. And when we look at all of our different products, we may have some very fast-moving products that don't spend much time in finished goods inventory. We may have a blend of build to order and make to stock products that we have within our portfolio. And then looking back through the supply chain, things take different amounts of time in production. Some things will go through multiple steps, multiple different facilities and so forth before they're finished with manufacturing. Some may have a simpler path. And then for the raw materials, those have different lead times from suppliers, different delivery schedules, different amounts of time that they spend in inventory and so forth. And so the reality of this picture is much more complex than just looking at kind of this average time that raw materials spend in inventory, the average amount of time in production, the average amount of time in finished goods inventory and so forth. And so when we want to actually visualize this, one way is to look at all of these averages and look at a very simple picture like this. But it could also be very instructive to have something that actually dives into the details behind all of this and allows you to see that on a product family basis, on an individual SKU level, SKU location level, and getting down into those details to show what is my shortest cash conversion cycle, what is my longest cash conversion cycle, and what does that entire distribution look like. And that way I can start to look for exceptions within there and so forth. And so just from a visualization point of view, utilizing some of the business intelligence tools such as Tableau or Power BI or a Click or something along those lines can be extremely valuable for diving into the details behind all of this information. And so being able to collect this data from ERP systems, from shop floor systems for that part of it and so forth, and being able to visualize how long all of this takes is something that can lead you to a lot of insights for how to reduce your average by taking your extreme cash conversion cycles and starting to understand why those particular ones are so long. All right. The next question that we probably have to ask is, why reduce that cash conversion cycle time? And if we think about the business as a money machine, essentially what we're doing is we're putting money in, we wait some amount of time and do stuff, and then we get more money out. And there's really two key things there. One is, how long does it take to get the money out? And that's our cash conversion cycle. And then the other is, how profitable is that time? How much more money do we get out compared to the money that we put in? And really, the longer that you tie up that money, the more profitability you have to have in order for the business to really be viable. So if we look at something like return on invested capital, there's two ways to change that return on invested capital. Again, one is that difference between money out versus money in. The other way is how much money you have to put in at one time. And so if you can reduce the amount of inventory that you're carrying, because that reduces your invested capital, now you kind of automatically increase your return on invested capital as well. And as far as something like economic value added, if we look at the diagram over on the right side there, I won't go through all the details of that, but reducing that cash to cash cycle time directly and indirectly increases your economic value added as a corporation. Another side of this is that cash flow is king. Cash flow is always king, but cash flow is king most certainly during uncertain times. And being able to speed up that cash flow, being able to convert that cash more quickly is going to help you as a business be much more agile and responsive to changing market conditions and so forth. And so, being able to create that agility while maintaining efficiency is going to help you have much more robust profitability through these kind of uncertain times. So with all that said, how do we go about reducing the cash conversion cycle? As I said on a couple of slides previous, one way to do that is to certainly look at the financial terms and reduce our days receivable and increase days payable. That's pretty much outside of today's scope. I'm more of an operations guy, and so I'm going to focus more on how we can actually look at that time that materials spend in process and think about how we can reduce that. And so with that said, the next step is looking at for that amount of time that materials spend in process, how can we reduce that? And we'll look at a few different ways. Primary among those are reducing the lot size and ideally achieving single piece flow within our operations, but also removing the non-value add time. So the time in between operations, the time that our work in process material gets stored, transportation time, things like that. From a raw material inventory perspective and finished goods inventory, those are really driven by a couple of different things. One is kind of the cycle time for deliveries, one from suppliers into production and then from production into finished goods. And so if you go a month between when you supply product A into finished goods, then you have to supply at least 1 month at a time in order to cover that cycle. And so if you can start delivering product A on a more frequent basis, or if you can start receiving part A from your suppliers on a more frequent basis, then that's going to help you reduce the amount that you have to carry. So we'll look at things like that as we go along. So in terms of reducing the production lead time or work in process inventory, the first thing is product cycles. So if we manufacture product A and then we manufacture product B and then product C and then product D and then go back to A, how long does that cycle take us and how can we reduce that? From a non-value add time, these are things like waiting, transportation time, WIP storage. How can we identify and eliminate those from production? And then the last thing to impact would be the actual time that we spend producing the part. And that's really the toughest to impact. And generally, it's a much shorter amount of time when compared to the rest of it. So let's look at those product cycles first. And I just did a presentation last week on reducing setup times when I talked about this very exact thing. And so when we look at normal setups and what we hear from kind of traditional manufacturing, if you think about the 1980s and so forth, big batches are much more efficient. Hate to do changeovers, hate plan changes to go, be flexible in terms of how much we're producing in a given time period and so forth. If you look at being able to reduce the amount of setup time, though, that reduces that friction of moving from part A to part B to part C and allows you to build in much shorter lots. So if you didn't have any time to change over from product to product, ideally you could run one product A, run one product B, run one product C, and essentially make to order as demand dictated. And so as you reduce setup time more and more, you get more and more towards that ideal. And so this has a number of benefits. The key one that we're looking at for today is the shorter lead times and the reduced variability. What that's going to allow us to do is to keep less material and finished goods and so forth, but it also simply reduces that amount of time that things spend in production. So going back to last week's presentation a little bit in terms of how we achieve this, the first step is to just benchmark all of the timings that we have in setups. Step 0 is to, once we've timed all of those things, determine whether this individual steps are something that can be done while the machine is still running versus when it is stopped. And then to reorganize those activities so that we do all of the internal changeover activities all in sequence, so that the external changeover activities can be done while we're still running the old product or while we're starting up production on the new product. And then additional steps to reduce that for improving those activities, eliminating activities, and then standardizing and kind of maintaining the new change-up routine. And that will help us dramatically reduce all of these different things. And what I talked about last week in terms of the impact of some of these Industry 4 solutions in being able to do this, things like the Industrial Internet of Things are going to help us to identify what are those tasks that are happening and what is the duration of time that they're taking, what are the ideal settings for the equipment and so forth, so that we can dial straight into those instead of kind of going through trial and error to get things set up correctly. With augmented reality tools, we can capture how the best people go about doing the process, and we can also use that for training so that everybody does the process the same way. For things like spatial computing and so forth, this can give us kind of a bird's eye view of the area and actually allow us to see what are all the non-value add steps that are taking place during this time, so that we can eliminate those and minimize the amount of time that operators have to spend walking and doing other things to actually change over the equipment from one product to another. The next step that we talked about was looking at non-value add time during production. And this is a typical value stream map that looks at the different processes that material has to go through between receiving and shipping. And when we look at a very typical map here, what we see is that we've got much longer times between operations. So this is 6 days, and then this is 300 seconds, and then 4 days and 45 seconds, 1 day and 240 seconds, and then 3 days before shipping. And so in the end, what we see is that we have 14 days of production lead time, but only about 10 minutes of actual production. and that's on a per piece basis. And the reason that this happens is that you get big inventory stores prior to each step in the process, so that you have all that waiting time in between the different steps. And what we're trying to do is to identify what are the reasons for those inventories in between processes, and how do we eliminate or at least mitigate those different inventory stores. And that's going to allow us to dramatically eliminate that non-value add time and really streamline the flow of things through production. Now, what lean manufacturing is really trying to do is to eliminate all of this inventory in between different steps and get to a point where you have single piece flow between process A, process B, and process C here. And then you basically have very little amount of time that material is spending in inventory. There are also strategies for how you smooth production so that you can give more reliable output from manufacturing to finished goods, and or also to your suppliers, so that they can have less uncertainty in terms of what you're going to need during production. And so that makes it easier for them to deliver on time as well. And so all of these things combined help you to really minimize that time for work in process. Now, from a raw materials point of view, there's a number of questions that really drive inventory here. And when we look at the supplier side of things, how frequently do those deliveries arrive? We talked earlier that if you only get a delivery once a month, then you have to get that order for at least 1 month of inventory. And the more uncertainty you have on the manufacturing side for what your consumption is going to be during that month, the more safety stock you have to add to that order in order to be able to have a high degree of confidence that you're not going to stock out. On the other hand, if you receive deliveries every single day from your supplier, then you only have to order 1 day at a time. You can make much more rapid adjustments to how much inventory you're ordering in any given day. And so you have a lot less safety stock that you have to put in place to cover uncertainty in what your consumption is going to be for just that 1 day. Now, it may not be feasible, especially if you have overseas suppliers and so forth. But the more you can do to shorten that supply chain, have local suppliers, is going to allow you to reduce that amount of raw material inventory that you have to carry and be able to minimize that. Now, there are also additional strategies here, such as consignment inventory and so forth, that would allow you to reduce that amount of materials or the time that you are technically carrying that inventory on your books. Now, from a manufacturing perspective, how much risk are you willing to absorb of a stock out? So how much is that going to impact your production in a given day if you stock out of one raw material? So if you have the ability to really rapidly flex from one product to another, it's not as big of an impact to run out of any individual item. And so you can carry less raw materials because you're not going to be as hurt if one thing doesn't show up. So again, being able to set up very rapidly is going to help you with this. Next, how long does it actually take to receive materials, inspect them, and then make them available to production? Because that adds to that lead time between when you receive parts and when you actually utilize them in production. And so if it takes, I've seen companies that have a week to 2 weeks for that receiving process to happen, that just adds to that amount of time for your cash conversion cycle. And then uncertainty or lumpiness in your consumption patterns are also going to drive more inventory of your raw materials that you have to carry. And so as much as you can smooth out production or reduce these lead times, better off you're going to be. And so looking at that kind of uncertainty in the consumption pattern and the lumpiness, if we look at the different causes of variation or uncertainty within the manufacturing process, it's really driven by man, machine, method, material, measurement, environment. But those top 3 are typically the biggest ones. And so, from that perspective, looking at these Industry 4.0 solutions, we can certainly help drive standard work so that people are doing the same tasks in the same ways all of the time. And we can identify deviations from those standards to make sure that we kind of retrain people, that we get that adherence to the standard work and so forth. And we can also bring new workers up to speed faster so that they're able to get to that productive state in a much more rapid fashion. In addition, if you look at something like the Kaizen cycle, or being able to conduct these continuous improvement events and so forth, every single step of this process is improved by the presence of data. And having the really rich and detailed data is going to help you identify the problems in the first place, analyze the process, brainstorm solutions, simulate those in advance of putting them onto the shop floor and so forth, measuring and analyzing the results and standardizing that solution across your different processes. From a finished goods perspective, again, on the manufacturing side, how long do we go from one run of product A to the next run of product A that we're going to feed into finished goods? And the more frequent that happens, the better off we are in terms of having to carry less finished goods. How much uncertainty is in that timing? And then, how much uncertainty in the quantity of goods supply going out to finished goods. And so those are things that, we look at those sources of uncertainty in manufacturing, and those are going to help us on the finished goods side, as well as the production and the raw materials. And then from a demand perspective, first of all, what is our acceptable lead time for delivery? If our acceptable lead time for delivery out to our customers for a given order is longer than it takes to get the materials from manufacturing, then we're in a position where we can just do that make to order and not carry any finished goods of that particular product type. Where that lead time is, instantaneous or whatever it might be, shorter than the time it takes to get them from production, then we're in the position where we have to carry finished goods inventory in order to be able to feed that demand in the acceptable lead time. And now we start to look at how much uncertainty do we have in those demand patterns, how much lumpiness do we have in those demand patterns, as well as what we've previously talked about on the supply side. So looking at that demand picture, what is going to help us there is better forecasting. And unfortunately, we live in a world right now that's very difficult to forecast. I was going to have Jamshid Iqbal from Cosmometrics here with me today. Unfortunately, this is the world we live in right now. And he's had an illness in the family that he's had to address. And so looking at that demand side for the statistical forecasting, one of the things that I want to address today is, how do you actually do statistical forecasting when the historical data for the past year or 2 years from a sales point of view is radically skewed. So in the past, what we've done from a statistical forecasting basis is to look at the previous 3 years of history, take that as our basis, look for seasonal trends, look at different causal factors and so forth, and then generate that statistical forecast based on that historical analysis. Well, when your history is completely skewed, how do you actually go about analyzing that and generating that statistical forecast going forward? There are a number of things that you can do to really look at how do we clean that up. But some of these different things that are on the screen now in terms of the demand classification and the automatic parameter tuning, being able to clean your history and look at missing time periods and so forth, looking for those underlying seasonal profiles and so forth are all very important. But it also becomes much more important to kind of weight what has been happening recently and to take that seasonal trend from history and so forth and really weight it based on the most recent events and be able to make those adjustments to your model so that it learns really how to respond to those changes in demand profile. The other key thing there is to reduce the amount of time that you have in the forecasting cycle. So if you forecast monthly and you go through a monthly S&OP process, then you're trying to forecast at least the next month of demand, probably the next couple of months of demand as you go through each cycle. And if you could reduce that to a weekly S&OP process, a weekly forecasting process, then what you would be able to do is only have to forecast 1 week at a time. And what that means is that you have to be able to respond within manufacturing to those weekly changes in that S&OP planning process. And by being able to reduce that amount of time, being able to respond quickly, change over more quickly, and so forth, that's going to help this entire process be more responsive to those rapid swings in demand that we're seeing in the market today. Another thing that's going to help is if you can do demand shaping, and this is going to be much more realistic for some companies than others, depending on your industry. But the more that you can do to shape the demand, whether it's from price manipulation or not manipulation, but price changes and how much elasticity you have in that, being able to run promotions, being able to put things on the end cap on the display and so forth. That's going to help you shape the demand to the things that you actually have. And the more you can shape demand, the more predictable it becomes. And obviously, the better you'll be able to match that from a supply chain point of view. This process where it becomes very difficult to statistically generate the demand or forecast the demand also means that the inputs from the people in the process are going to become more important. And so, being able to do this consensus forecasting process where you get inputs from the customers directly, from marketing, from sales, and marrying that and blending that with the consensus or the statistical forecast and how much you weight each of those different inputs based on the quality of that input is a very important capability that you need to have embedded into your forecasting process to really drive a lot of these changes and be able to reduce the amount of inventory that you're carrying in the system. And the forecast, and I can't emphasize this enough, if you forecast accurately, not only helps you with finished goods, but it goes all the way back into your raw materials. If you forecast the right things in the beginning, you're going to buy the right materials and you're going to have those materials in stock. It's going to help you keep your production smooth because you'll have those things in stock and you'll be able to build what you want at any given time. And so this upfront process of forecasting smooths a lot of those later errors in the supply chain. And finally, from a forecasting point of view, we don't often think about root cause analysis from forecasting errors, but we really should look at that process of how do we run a continuous improvement on the forecasting itself. And so there are different reasons why our forecast might be inaccurate. Some of it is just the random nature of demand and different unplanned events and so forth. But there are also ways that we can look at to identify these different causal factors and mitigate those over time so that our forecast becomes more and more accurate as we go along. And so make sure that you have that baked into your forecasting process, that you're looking not only at continuous improvement happening on the shop floor, but within your forecasting process as well. So with that, that's the end of today's webinar. Please enter any questions that you have into the Q&A. Just a quick word on upcoming webinars. Next week, I'll be talking about the visual factory, what that looks like in 2022, and how we utilize things like the industrial Internet of Things to really create those visual controls on the factory floor that are going to create positive feedback loops with your people so that you can really drive better production and better morale and things on the shop floor. Then we'll be looking at 8D problem solving and how we bring a smart and lean approach to that, implementing Industry 4.0 the right way, fighting performance entropy, and then how do we take a step back and look at this digital transformation of operational excellence and really driving smart and lean within our organizations. So with that, I want to thank you all very much. If you have any questions, please reach out to me at tim@visualdecisions.com or at 630-957-8096. Thank you. Bye-bye.